everyone. Today's lesson is a pretty big one because you're going to learn how to use the formula sheet that you're going to be given on the actual AP exam. So it's really important right now that everybody has the AP Statistics formula sheet in front of them. So if that hasn't been distributed yet, please pause the video and take time to distribute that. This is yours to keep. You can write notes to yourself on it. That's fine. You're going to use it to do your homework. You need to have it with you in class every single day from here on out. However, on quiz and test days, you're going to get a clean copy of this. So that's why it's okay that you write some notes to yourself on it because you're going to get a clean test and quiz copy whenever you need it for quizzes and tests moving forward. Set that aside for now. I'm going to come back to it in just a minute. So we've been talking a lot about the normal distribution, and we also learned that in the normal distribution, we have this 68, 95, 99.7 rule. So if you go out one standard deviation in both directions, you capture about 68% of observations. 2 standard deviations gives you 95, 3 standard deviations gives you 99.7%. The goal of today's lesson is to be able to answer questions similar to those 68, 95, 99.7% questions. However, we're going to learn how to handle situations where I'm not exactly 1, 2, 3 standard deviations above or below the mean. So it's important to note that all normal distributions share certain properties, and if we measure them in terms of the mean and standard deviation, they're actually all identical. What I mean by that is, if I standardize every single observation, so say I have a huge set of data that's approximately normal, maybe it's about blood pressure, and let's say I take every single individual's blood pressure and I convert it to a z-score. So I take that person's blood pressure minus the mean divided by the standard deviation, and I do that for everybody. That new distribution will still be normal. Okay, and now instead of the x-axis representing blood pressure specifically, it represents the z-scores of blood pressure. And if I do that for, let's say, 2 different normal distributions, if I standardize, if I z-score 2 different normal distributions, then the resulting z distribution is going to be identical no matter what. So we call this the standard normal distribution. It's a normal distribution. It has a mean of 0 and a standard deviation of 1, okay? And so if I standardize any normal variable, what I end up with is this standard normal curve, which, like I said, has a mean of 0 and a standard deviation of 1. The reference sheets that I gave you have tables that give you the area under the standard normal curve to the left of a certain z-score. So what I'm going to do now is start to show you how to use those, okay? Let's take out those reference sheets. I'd like you to take those out. Mine isn't going to look exactly like yours because mine's from a different year than yours. But they're going to look roughly similar. So what you're going to see on the first page are some formulas. We're going to kind of bypass this for now, okay? These are here. You're going to recognize some of these somewhat. For example, that first one is the formula for the mean of a set of data. That second one is the formula for standard deviation. But I'm mostly going to breeze past through these. So that's the first, second, and third pages. The third page has these boxes. And then you're going to see, if you're paying attention to page numbers at the bottom of these reference sheets, the page number jumps. Not quite as much as mine's going to. Let's see if I can find it. Yours doesn't look like this. Don't worry. Here we go. It's going to jump to some of these tables, okay? And so you have a page that looks like this. It's got a normal curve with the left shaded, and then it's got sort of all these numbers. And then on the opposite side is another page with a normal curve where the left is shaded, but now it's a bigger area. And you have these. And then you have 2 other sets of tables. For right now, I want you to completely ignore, as in never, ever, ever use these last 2 pages. Okay, these are a different distribution. We will deal with them eventually this year. But right now, I want you to focus on the 2 pages with z-scores. Okay, they're called Table A. in your reference sheet. So hopefully everybody is on this page with me. I want to show you how to read these tables. Every year I have students ask me, oh my gosh, Ms. Kramer, do I have to have these tables memorized? Of course you do not. Okay, as I said, you're going to have access to these tables for every classwork, homework, quiz, test, AP exam from here on out. Okay, so what you do need to know is how to read them. Within the tables, this left column here gives you the ones and tenths place of the z-score that you're trying to look up. This very top row gives you the hundredths place. And what you're essentially going to do is piece together the ones and tenths place with the hundredths place and read off the percentage from what I call the guts of the table. All right? Now, you also need to figure out which side of the tables to use. That's actually pretty easy because this page, the one with the smaller area shaded to the left, only has negative z-scores, whereas the next page, the one with the bigger area, only has positive z-scores. So the first thing you're going to do is you're going to look at your z-score and ask yourself if it's positive or negative. Then you're going to piece it together using the ones and tenths place in this column and the hundredths place in this row, and trace until you get into the middle, the guts of the table. That number in the guts represents the percent of observations to the left of that z-score. Okay? And so I'm going to return to the notes and we're going to do a couple of examples. So first question, find the percent of observations in a normal curve that are less than z equals 2.22. Okay? So 2.22 is a positive z-score. So I'm going to go to the second page of the tables. Hopefully you're with me here. The ones and tenths place would be 2.2. So I'm looking in this row. What's in the hundredths place of 2.22? Well, it's a 2. So I'm going to match that with this. And so I trace, you can't tell this now, but I'm using my fingers to kind of trace into the guts of the table. And what I get is this 0.9868. And so the answer to that first question, what percent of observations are less than 2.22, is 0.9868. Okay, and that should make sense because in a standard normal curve, we're looking at 0, 1, 2, 3, negative 1, negative 2, negative 3. 2.22 is right about here. Less than means I shade to the left. It's like a number line. Is it believable that that's 98.68% of the curve? Sure. Okay. The second question, find the percent of observations that are more than z equals negative 0.25. Okay, now this part's a little bit tricky because I said more than. So here's my curve, 0, 1, 2, 3, negative 1, negative 2, negative 3. Negative 0.25 is 1/4 of a standard deviation to the left of the mean, negative 0.25. And more means I'm going to shade to the right. Now this is a little bit problematic because as I told you, the tables always shade to the left. Before we look it up, let's strategize. I'm going to look up negative 0.25 and it's going to give me this area right here. But what's the total area under this curve? It's 1. So I'm going to do 1 minus whatever I look up from the tables because I want shaded to the right, and the tables are automatically going to give me shaded to the left. So let's go to our tables. This time I want the negative side. Okay, here I am. Negative 0.25. So my ones and tenths place is negative 0.2. It's way, oh darn it. It's way, here we go. way down here, negative 0.2. And then my hundredths place is 0.05, that's right here. And when I do that, I get 0.4013. Now wait a second, because I'm not done. I got 0.4013, but remember, that was the area to the left, and I wanted the area to the right. So I need to do 1 minus 0.4013, and I'm going to get 0.5987. So the answer is 59.87% or 0.5987. Guys, you can leave these as a decimal or you can rewrite them as a percent, whatever you feel more comfortable with. I have a slight preference towards leaving it as a decimal, but it really is up to you. Let's do a few more examples. I want to find the percent of observations that are less than 0.5, more than 2.27, between negative 1.1 and 1.19, and between 1.56 and 2.56. So with each of these, I'm going to do the first one, and then you're going to pause, and you're going to do the second one. Okay, so the first one, less than 0.5. Well, 0.5 means 0.50. The hundredths place is going to be 0. So I'm looking at 0, 1, 2, 3, negative 1, negative 2, negative 3. Positive 0.50 is right here. Less than means I want to the left. And so I'm going to go to my tables. And the first thing I'm going to notice is that this is a positive z-score. So I'm going to start on the page with the positive z-scores. And I see that the ones and the tenths place are a 0.5. And so I am looking here, and I see that the hundredths place is a 0, so I'm looking in the very first column, that's 0.50, and I get 0.6915. 0.6915, and that's my answer. That's it. Okay. Similarly, I would like you to find what percent of observations are more than 2.27. So please briefly pause the video, help your neighbor if they don't understand, and find the percent of observations that are more than 2.27. I'm going to start by drawing a curve again, and you may be wondering, do I really need to draw this same exact curve every single time? Well, guys, this is just one step in a very important multi-step process, okay? And so for right now, yes, because that curve is going to become very, very important, just like it was with those 68, 95, 99.7 problems. So here's 2.27. More than means I shade to the right because it's a number line. And so hopefully you went back to your tables and looked up 2.27. So I see 2.2 down here. And the hundredths place is 0.07, which is right here. And when I match those, it's kind of hard on the eyes, so just be careful. I see 0.9884. 0.9884. So hopefully that's what you pulled off of the tables was 0.9884. But I'm hoping you didn't stop here because we shaded to the right. This is clearly not 98.84% of the curve. When we shade to the right, we need to do 1 minus. And so my final answer is going to be 0.0116. Does that look like it could be 1.16% of the curve? Sure. All right, my next question I'm going to do, and then we'll pause the video and you can do the last one together, or last one without me. And it's between two of them. Okay, we haven't done one like this. And so I'm going to start by drawing my curve. 0, 1, 2, 3. -1, -2, -3. Negative 1.1, now remember that's negative 1.10, the hundredths place is 0 there. And positive 1.19. And between means I'm going to shade, well, between those two. What you have to do to use the tables to find a between area, you're going to look up the larger of the two, so in this case 1.19, and then you're going to subtract whatever is less than that, the negative 1.1. So essentially I'm going to look both of these up and subtract them, because looking up 1.19 is going to give me all of this, because I shade to the left, and then subtracting the area that's less than negative 1.1 is going to get rid of all this and leave me what's in the middle. So let's start by looking up the larger one, in this case 1.19. So I'm going to the positive side. 1.1 is here, and then 9 in the hundredths place means I'm looking at 0.8830 is what I get. .8830 minus, I'm going to look up the one that's further to the left, negative 1.1. So again, back to my tables. Now this one's negative, so let's look on the negative side. Negative 1.1, and then the hundredths place is 0, so 0.1357. 0.1357. And what you're going to do is subtract those two areas, because I want the area between negative 1.1 and positive 1.19. So when you subtract those two, you should get 0.7473. And that's it. That's your answer. Hopefully that was clear enough. I'd like you to pause the video and do this last one without me. And then when you unpause, I'll go over it. So this is another between area, 1.56 and 2.56, both of which are positive. Okay, let's draw our picture. 0, 1, 2, 3, negative 1, negative 2, negative 3. Positive 1.56 is right about here. Positive 2.56 is right about here. It's kind of hard to draw them that close together. I want between those two. So between means I'm going to look them both up and subtract. Let's look up positive 2.56 first. 2.56, I'm going to go to the positive side. 2.5 is right here. And when I match that into the 6 in the hundredths column, I get 0.9948. 0.9948 minus, now I need to look up positive 1.56. 1.5. And I get 0.9406. Which when I subtract those, I get 0.0542, which is my answer. Now you may be wondering what the point of all this is. And we can use this technique to solve problems, to solve word problems involving normal distributions. And these are the 4 steps that you'll need in order to do that. So what we're going to have to do is make sure we understand the problem in terms of X, in terms of the actual variable we're given. Maybe it's height, weight, blood pressure, something like that. Then in step 2, we need to standardize our variable and draw a picture in terms of Z. Okay, and so basically we're going to draw the normal curve, shade it, and then find z-scores associated with the numbers in the problem. Then step 3, we're going to use our table to find the area. And step 4, we're going to rewrite our conclusion in the context of the problem. Let's just go ahead and start with an example. So this says that a standard IQ test, which has an approximately normal distribution, has a mean of 110 and a standard deviation of 25. And the question is, what percent of people have IQ scores between 95 and 120? At first, this sounds like one of those 68, 95, 99.7 problems, but you're going to find that these numbers don't work out as nicely. We're not exactly 1, 2, 3 standard deviations above or below the mean. For step 1, stating the problem in terms of X, all I really want you to do is draw and shade a picture. So here's my picture. I know it says to draw a picture in step 2, but this is what I actually want you to do. The mean is 110. I'm going to go up 1, 2, 3, down 1, 2, 3, and I'm going to label them accordingly. So if the standard deviation is 25 and the mean is 110, then if I'm one standard deviation above, 110 plus 25 is 135. And then if I add another 25, I'm at 160. And if I add another 25, I'm at 185. Let's do the same thing in the other direction. If I go one standard deviation below the mean, I'm at 85. 2 puts me at 60. And 3 puts me at 35. Okay. Now, I want between 95 and 120. So 95 is going to be right about here. 120 is going to be right about here. And I want to shade right in between. Guys, this step, drawing and shading and all that, you're going to get annoyed with it, but it's too bad. You have to do it. This is absolutely non-negotiable. So that's it for step 1. Step 2 is standardize the variable, meaning calculate z-scores. So the z-score for 95 is 95 minus the mean, 110, divided by the standard deviation, 25. And that gives me a z-score of negative 0.6, and I'm going to write it as negative 0.60. I'm going to always take my z-scores to the hundredths place because that's how the table works. Then the z-score associated with 120 is going to be 120 minus 110 divided by the standard deviation of 25. And that gives me positive 0.4. And again, I'm going to write it as 0.40. And we're done with step 2. We calculated z-scores. Now I'm going to use the tables to actually answer the question and find this percentage. So I know this is a between problem, so I need to look them both up and subtract. I'm going to start with the larger one, which is 0.4. So let's go to our tables. We're already at the positive side. So, or at least we were. 0.4, and then 0 in the hundredths place is 0.6554. .6554 minus negative 0.60. So now I need to go back to my tables on the negative side. Okay, so here I am. Negative 0.6, and then 0 in the hundredths place is 0.2743. And if I subtract those, I get 0.3811. Numerically, that is my answer, but in step 4, I need to rewrite my conclusion in context. To do this, I'm going to read the question. What percent of people have IQ scores between 95 and 120? Well, 0.3811 of people. Or if you wanted to write 38.11%, that's fine, of people have IQ scores between 95, and 120. So to reiterate, we started by drawing our picture, shading in the appropriate area. Then we convert our raw values into z-scores. We use the tables to find our numerical answer, and we rewrite our conclusion in context. I'm going to do one more with you, and then I'm going to have you pause the video and do one by yourself. The mean amount of Pepsi that a fountain machine dispenses for a medium is 19.8 ounces, with a standard deviation of 1.2 ounces. Assuming a normal distribution, what percent of medium cups will have between 18.5 and 22.6 ounces? Now, this sounds similar to a problem we did when we were learning 68, 95, 99.7, but you'll see that these numbers don't work out as well. So in step one, I'm going to draw my normal curve. The mean is 19.8, and I need to go up 1, 2, 3, down 1, 2, 3. So if the mean is 19.8 and I add one standard deviation of 1.2, I end up at 21. And then 22.2, and then 23.4. If I go in the other direction and subtract standard deviations, I go to 18.6, 17.4, and 16.2. My question says between 18.5, which is right here, and 22.6, which is right about here, and I shade in the middle. The shading is important. All right, in step two, what do I need to do? I need to calculate z-scores. Pause the video right now, and I just want you to calculate your two z-scores. So please pause the video for 1 minute and allow students to calculate z-scores. There should be 2 of them, one for each of these numbers. All right, for 18.5, I get 18.5 minus the mean divided by the standard deviation, and that gives me negative 1.08 is what I'm going to round to. And then the z-score for 22.6 is 22.6 minus the mean divided by the standard deviation. And that is 2.33. And that's it for step 2. For step 3, I need to find the area between those two. Again, there are 2, so I'm going to look them both up and subtract. Positive 2.33, I need to go to the positive side. Here's 2.3. I'm going to move into the 0.03 column, which is 0.9901. Did we get that? Minus negative 1.08. Going to go to the negative side. Negative 1.08 gives me 0.1401. Which I subtract, and I get 0.8500, or 85%. So my answer in context, 85% of medium cups will have between 18.5 and 22.6 ounces. All right, one more problem, and for this one you're on your own. The distribution of blood cholesterol levels in a large population of people of the same age and sex is roughly normally distributed. For 14-year-old boys, the mean is 170 milligrams of cholesterol per deciliter of blood, and the standard deviation is 30 milligrams per deciliter. And it does say that it's roughly normally distributed, so there's my distribution. What percent of 14-year-old boys have more than 247 milligrams per deciliter of cholesterol? This one is a more than, so you're not going to be shading between 2. You're just going to be shading to the right. And you're not going to have 2 z-scores to look up, you're just going to have 1. Please pause the video here and take 5 minutes to go through all 4 steps with this problem, and please help your neighbor if they need it. All right, hopefully you started with step 1, drawing your curve. The mean is 170. If I go up 1, 2, 3, down 1, 2, 3, I'm adding and subtracting 30, so this becomes 200, 230, 260. To the left, that becomes 140, 110, and 80. More than 247, 247 is right about here. More than means I shade to the right. So there's step 1. Step 2, I calculate my z-score, which is going to be 247 minus the mean divided by the standard deviation. And I believe that gives me positive 2.56. Or you could have called it 2.57. In this class, I do not care if you round or truncate. Round means following rounding rules, and you would get 2.57 because 2.566 rounds up. Truncating means chopping it off after the second decimal point in this case, which would give you 2.56. You can do either. It doesn't matter. It truly does not matter. In a problem like this on a quiz or a test or the AP exam, they'll have worked it out both ways. Okay, so I'll solve both ways. Let's look up both of these, 2.56 or 2.57. I'm going to write or here. If I look up 2.56, I need to be on the positive side. 2.5, and I get 0.9948. If I looked up 2.57, I get 0.9949. They're so close it isn't even going to make a difference. So 0.9948 or 0.9949. Now I'm really hoping neither of these were your answer because it says more than 247. I shaded to the right. I need to do 1 minus because the table gives me the area to the left. So 1 minus, either of those numbers are fine. And you get 0.0052 or 0.0051. And so step 4, my answer is 0.0052 or 0.0051 of 14-year-old boys have more than 247 milligrams per deciliter of cholesterol. All right. That's it for today's lesson. And so here is homework number 3. Tomorrow's lesson is going to teach you how to do the same thing but in reverse. So starting with a percentage, how do I work back to a certain raw value?